Now we will watch a small documentary about the moon and about the stars and the suns, so that when after I explain, you understand what I'm talking about. We will watch a small documentary explaining about the suns and the universe, something, little information, so that when I speak about them, you understand what I'm talking about, okay? Watch so that you learn a little about the universe.
The ancients believed the stars of the night sky were eternal and unchanging. Today we know this is not true. Stars are born, live their lives, and then die. The way a star dies depends largely on its mass. A low mass star ends as a white dwarf.
Okay, you know what she's telling? She's telling a small sun, when it dies, it becomes like a small white dwarf, a small ball. For example, our sun is a small. If it dies, it becomes like this. White small sun becomes when it dies. Okay, watch again.
A high mass star becomes a black hole.
Okay.
And in between, a star.
Okay. When a sun bigger than our sun million times dies, it becomes a black hole. And when a sun between these two, small and big, medium size, when it dies, it becomes a neutron star. This is the universe. There is the three types of suns: small, medium, and big. Okay? There is a question you didn't understand? There is three kinds of suns. Small sun, when dies, becomes like this, white dwarf. When a medium sun dies, it becomes a neutron star. When a very big sun dies, it becomes a black hole. You have any question about this? When it dies, when its fuel is finished and the gravity collapses, it will become like this.
Every million of years?
Yes, but every million of years, yes. But there is suns in the universe, they have reached million years, they are dying. We will understand little by little. But this subject, you know about, there is three kinds in the universe. Small sun, medium sun, and big one. Small dies like this, the medium dies like this, and the big one like this. We will continue, so that after when I speak, you understand what I'm talking about.
Star becomes a neutron star. Stars spend their lives fusing matter together. This process begins with the simplest of atoms, hydrogen. Fusing hydrogen nuclei gives you helium and releases some energy. It's this energy which causes the stars to shine. If the star is big enough, then it continues to evolve by fusing matter together to make heavier elements: helium, carbon, neon, oxygen. But at some point, the star runs out of steam. Fusion stops, stellar evolution comes to an end, and the star dies. Smaller stars end their lives as a white dwarf, a glowing ball of white-hot matter which slowly cools down over billions of years. Although fusion has stopped for white dwarfs, they still shine because of their astronomically high temperature. This is the death that awaits our sun.
Our sun will die like
For the really big stars, the end of fusion enables gravity to do some real damage. Unconstrained by fusion, the gravity of the star breaks down particles and squeezes everything together as tightly as nature will allow. The result is a black hole. The gravity of a black hole is so strong.
Three kinds of suns. She's explaining how they die.
Including light.
Black hole, neutron star, white dwarf.
Yes. In between white dwarfs and black holes are neutron stars. These stars are made primarily of neutrons, which are neutral particles. Ernest Rutherford predicted the existence of neutrons in 1920, and a dozen years later they were observed by James Chadwick. You can find neutrons in the nucleus of most atoms. They can also be created in a process called electron capture. With enough force, a proton and electron combine to form a neutron and a neutrino. Neutrinos are super fast and elusive, so they just fly off. But the neutron stays behind. This is the key to understanding how neutron stars are made.
This is middle sun.
Imagine you have a dead star, about 50% more massive than our sun. The star's gravity is strong enough to squeeze the electrons and protons together to form neutrons and neutrinos. The neutrinos dart off into space, leaving behind a big sphere of neutrons.
It becomes highly magnetic.
Squeeze the neutrons together, but eventually hits the wall. The Pauli exclusion principle. This says roughly that two particles cannot occupy the same place at the same time. You now have a neutron star. Let's quantify the transition from white dwarf to neutron star to black hole.
Now you will
Suppose we
understand.
have a dead star and an imaginary dial that lets us change its mass.
Okay.
We'll set the dial to one
Okay.
solar mass, the mass of our sun.
Okay. What she's speaking here, it's important so that you understand. This is one stellar mass, mean from our sun to the ninth planet. If the sun if it's the sun size, it will die like a white dwarf. This is the first sun. Okay.
This produces a white dwarf, a spinning sphere of white-hot matter about the size of the Earth. As we increase the mass by turning the dial, gravity gets stronger, the white dwarf gets smaller, and it spins forward. Once we turn the dial to 1.39 solar masses, gravity is strong enough to combine electrons and protons to make neutrons and neutrinos. This value on the dial is called the Chandrasekhar limit. The dead star is now a neutron star. It shrinks down to a sphere with a radius of about 10 kilometers, and the spinning can be as fast as hundreds of times per second. If we move the dial further, gravity eventually becomes strong enough to break down the neutrons, and the neutron star collapses into
Become a block. Three kinds of
White
stars.
diamond is called a total
White
envelope
dwarf, neutron star,
and while its
and the black hole.
diameter is unknown,
Okay?
it ranges
This is
from
in all the
1.5 to
universe.
3 solar masses.
White dwarf, neutron star, and
If
black
you want to
hole.
look at the ingredients of a neutron star,
This is the middle sun.
neutrons. The number one ingredient is definitely neutrons, but there are still some protons and electrons in there too. Because a rapidly spinning neutron star contains these charged particles.
Look, neutron stars in the middle sun, what's doing?
Just like on Earth, the
It
magnetic field
blinks.
doesn't have to line up with the axis of rotation.
Look, it blinks.
Like a stellar lighthouse.
The middle sun like this. We will speak about this after.
With regular bursts of electromagnetic.
This is the middle sun.
Because of this
The middle
pulsing
side.
signal, neutron stars are sometimes called pulsars.
It called also pulsar. Why
Neutron
is
stars like
pulsar? Neutron star is also called a pulsar.
Almost as soon as a neutron was detected, astronomers Walter Baade and Fritz Zwicky predicted that a supernova could produce neutron stars. And in 1967, a pulsating neutron star was first observed. In the decades since, many more have been discovered.
Okay, now you took idea three kinds of suns. Our sun, that when it dies, it becomes a white dwarf, a small sun, white. The middle sun, the bigger one, when it dies, it becomes a neutron star. They call it also a pulsar because it gives a pulse. And the bigger size suns, when it dies, it becomes a black hole. It's easy. This is how the universe works. We will speak about these three. All the universe is made of these three kinds of suns. Now we will watch about a Quranic verse. It's speaking about the sun. It's telling, is a shams kowira, if the sun becomes a ball. When the sun will be rolled, folded, compressed. What means kowira? Look what they translate, wrapped in darkness. Look what overthrown. This is the translation of kowira. You know Arabic. It's covered. Kowira, it's covered. I will tell you what it's mean, kowira. This is Arabic. This is Arabic, I will show you.
Kowirat's way round.
No, kowirat. Look what it's kowirat. Kowirat ثم رددنا لكم الكرة, mean again, become bold again, repeated, become bold again. كورت كرر, يعني لو قالوا لنكرر, يعني again, repetition. It means الشمس كورت becomes bold again becomes a ball. It's a ball, the sun. But كورت means it becomes a ball again. We will see that if our sun will become a ball again. If it becomes a ball again, then the verse is true. We will watch a video to see if the sun becomes a ball again.
As the hydrogen gets used up, it slows down the fusion at the star's core. This gives gravity the edge. With less fusion pushing outward, gravity crushes the star in on itself. But fusion fights back, heating the star's outer layers.
When you heat up a gas, it expands. And so the sun will actually expand up. Instead of being 1,000,000 miles across like it is now, it'll swell up until it's about 100 million miles across.
Our sun will become a red giant.
Imagine a sunrise, 7 billion AD. It's not just a little yellow disk coming up all cheerful and nice. What you would see is a huge, swollen, bloated red disk slowly reaching up over the horizon. And when the sun is fully up in the sky, it's blasting down heat on the earth. It would be like sticking your head in an oven set to broil.
Temperatures here on Earth will reach thousands of degrees.
The oceans will boil, the mountains will melt, and we'll have the last nice day on the planet Earth.
Then, the bloated star will engulf the Earth. But the giant red star is self-destructing. Its core becomes dangerously unstable. With no hydrogen left to fuel it, the star begins burning helium and fusing it into carbon. The star is now destroying itself from the inside out, blasting violent surges of energy from its core to its surface. These energy waves blow away the star's outer layers. Slowly, it disintegrates. The star is dead. All that remains is an intensely hot, dense core. The red giant
Look what
has
happened
become
to
a
the
white
sun.
dwarf.
The sun died and made a ball. The sun dies like a ball. This is a shams kawira. Look, it's dying like a ball. The only sun, only our sun dies like this. The other suns, they don't die like this. The size of our sun, when their energy is finished,
The other sun, how they die?
we will watch this again. If this sun died and became a ball, our sun, it's a white dwarf. The first one that we learned about it, yes. Small sun. Now we